السلام عليكم ورحمة الله وبركاته. أسعد الله صباحكم جميعا. إن شاء الله اليوم مكملين معاكم ب بارت ثيرموداينامكس، والمرة الماضية وصلنا لحد هذا السؤال وشرحنا مادة ثيوري بس ما بدأنا حل. طيب اليوم إن شاء الله هنكمل معاكم بالحل، وخلينا نبدأ مع هذا السؤال. So here we have a rigid tank contains 10 kilogram. Okay, so this is mass. And rigid tank means there is no change in the volume. Okay, and the substance here, so a rigid tank contains 10 kilogram of water. This water is the substance. Okay, so if we are going to use thermodynamic tables, we must go to the water table. So this water is at 90 degrees Celsius, so this is the temperature. If 8 out of 10, okay, so this is the total mass. Okay, so if we have 8 kilogram of water is in liquid form and the rest is in vapor, so we have M total equal to 10, and this is equal 8 plus 2, where 8 is the M F and 2 is the M G. Okay, this is vapor phase and this is the liquid phase. So this is a tank and 8 kilogram filled with water, liquid water, and here we have 2 kilogram of gas phase. Okay, determine the pressure in the tank, determine the volume of the tank. So as a starting point, we must go to the saturated table. So let me go to the solving board first. So here what do we have? We have M total equal to 10 kilogram. We have M in liquid for 8 kilogram, and we have M in vapor which is 2 kilogram. Okay, and the temperature is given, which is 90 degrees Celsius. What else? So this is the every information given in this problem. So I mentioned earlier, in order to go to any table, we need at least two information. Okay, so here is the first information. This is the first information. What is the second information? Do you know? Yes, it is mentioned, it is gas and the rest is liquid. Okay, fluid and gas. But that does not mean we have to read the information. The second information, if you think a while for a while, like 5 minutes, and you stop the video to discover the second property, you will find out that the other property is the quality. How we can calculate the quality? So quality will equal to, do you remember the general definition? Mass of the vapor divided by mass total, and it is equal 2 divided by 10 and quality equal to 0.2. Okay, so that means if we have equality equal to 0.2, in the last or in the previous lecture we learned that if equality between 0 and 1, that means we are in saturated mixture region. Okay, remember we mentioned this. Okay, so if the quality is between 0 and 1, which is now 0.2, that means we are in the saturated mixture region. That means the pressure needed in the first part must equal to be set in the table. Okay, because here we have 90 degree and here is the quality 0.2. We are in the saturated mixture region, and the question asked about is equal to B set. So let me go to the thermodynamic table, and I'm interested in visiting this table, saturated water temperature table, FA4. Okay, so let me go to A4. Here it is. So we have temperature of 90, this one, okay, and here is the pressure. So the pressure is equal to 70.183. So part A, E equal to B set, and it's equal to 70.14. Okay, so this is the first part. Now the second part is calculate the volume of the tank in meter cube. Volume of the tank. Volume of the tank must equal to mass multiplied by specific volume. Okay, we have the mass, but we don't have the specific volume. Now we need to calculate this volume. In order to calculate this volume, we need to benefit from this equation, which is equal to Vf. Remember this equation, plus quality multiplied by Vg minus Vf. Okay, so this is equal Vf. From where we can get it? From the table. Okay, where is the table? Here it is. So here is Vf, 0.001036. So here I can write 0.001036 plus 0.2 multiplied by Vg minus, Vg, which is 2.3593. Okay, 2.3593. Okay, minus Vf, which is 0.001036. This is equal V equal to specific volume 2.3593 minus 0.001036 multiplied by 0.2 plus 0.001036. So specific volume equal to point. It seems that I'm not on the solving board. So here is the volume, here is the specific volume, and Vf equal to 0.001036 plus 0.2, which is the quality, Vg 2.3595, and Vf 0.001036. Okay, so those value we get from here, this one and this one. Okay. Now if we use calculator, we'll find that V equal to 0.4726 meter cube per kilogram. Now if I need to calculate the specific volume, or the volume, for this tank, which is equal to 10 multiplied by 0.4726, and this is equal 4.726 meter cube. So this is the example number 5. Okay, let me go back to the slide. So yeah, we can We get pressure and the volume of the tank in this case. Let's see another example. Example number 6. So in this example, we have 80 liter vessel contains 4 kilogram of refrigerant. So here is the substance. This is the substance. And here is the mass of the substance, total mass. Okay, and here we have 80 liter. This is what? This is the volume of this vessel. Okay, so this refrigerant is at pressure of 160 kilopascal. Determine the temperature of the refrigerant, the quality. So we need T, we need X, we need the enthalpy of the refrigerant, and we need the volume occupied by the vapor phase. So we need B, G, okay, in meter cube. Okay, let's go to the solving board and write the given information. Okay. So the given information, we have volume, which is equal to 80 liter. Now this 80 liter, I need to convert it to meter cube. So every 1 meter cube give us 1000 liter. So liter with liter cancel out, and we end up with 0.08 meter cube. And the total mass is given also, which is 4 kilogram. Okay, so the substance is given, which is refrigerant 134A. Okay, and we have pressure also, which is equal to 160 kilopascal. We need to find the temperature. B, we need to find the quality. C, we need to find the enthalpy. Okay, so either H or lowercase h. Okay, so we might find the enthalpy, not this one, because if he asks about the specific enthalpy, he will write the specific enthalpy. Okay, D, we need to find Vg, volume, not the specific volume. Okay, now in order to find all of this information, we need at least two information. We have the pressure, which is 160 kilopascal, and we need another information. What do we have? We have the type of the substance, we have mass and volume. So what do you think? What is the second information? Second information is the specific volume, which is equal to V capital divided by mass. So V capital, which is 0.08, divided by mass, which is 4 kilogram, and the specific volume is equal to 0.002 meter cube per kilogram. So yeah, this is the two information. Let me write them again. So we have pressure equal to 160 kilopascal, and we have specific volume equal to 0.02 meter cube per kilogram. So we have two information now. We'll go to the thermodynamic tables, but I'll not use the water table. Okay, so I'll go and find out which table is the pressure table with a substance refrigerant. So here it is, saturated refrigerant, pressure table, A12. Okay, so this is A6, A11, and here is A12. We have a pressure 160. Okay, 160. Now, what we'll do, we have a specific volume. So this specific volume, the value that we have here, we must go to the saturated table and compare this volume with, or this specific volume with VF and VG. Remember, this is the first check. Okay, we have two information. Now we need to compare this value. Okay. So here is VG. VG equal to 0.12348. Okay. 0.12348. And the other value is point triple 07437. That's it. Okay. So is the value here, or is this relation correct? Is 0.02 greater than 0.007? Yes. If this value less than 0.1? Yes. So if this relation is correct, so once they are correct, that means we are, yes, we are in the saturated mixture region. Okay, remember the check. Let me go back and refresh your mind. So here it is, the saturated. Okay, vapor liquid. So at a given pressure, this is the case here, at a given pressure. So if this relation is correct, that means we are in the saturated mixture region. Okay, so this is what happens with us. So both of them correct. 0.02 between 0.02 between 0007 and between 0.12348. Okay, so that means go and benefit from this table. Do not go to any table. Just stick to saturated table. So here is 160. What do we need? We need to find, oops, we need to find temperature. Okay, we need to find temperature. We need to find equality. We need to find enthalpy. We need to find the volume occupied by gas, and all of them will get all of them from the saturated table. Okay, let's start with one by one. But before, or I can find directly the temperature. So if I'm in the saturated table, that means the temperature that we have must equal Tsat, and this is equal minus this value, minus 15.6. Okay, so this is minus 15.6 degrees Celsius. Part B, we need to find the quality. Okay, now in the statement of the problem, we have the specific volume. Okay, or we could find the specific volume from the statement of the problem. So we can go directly and benefit from this equation. V must equal to Vf plus X Vfg, or Vg minus Vf. Okay, or X must equal to V specific volume minus Vf divided by VFG or VG minus VF. Just rearrangement. So V, which is equal to point, let me change the color. V equal point 0.02 minus point 0.007 I think, divided by 0.12348 minus 0.07437. Okay, so if I use my calculator, we'll find that x equal to 0.02 minus 0.00737 divided by 0.12348 minus 0.00747. And here is the x, 0.156. Okay, so this value give us an indication that 50% of the total mass is vapor. Okay, so only 50% is vapor. So if I want to draw this state on a BV diagram, this is extra. Okay, BV diagram or TV diagram. So let me choose TV diagram, and here is the dome. Here is the pressure line. Okay, so where is the location of this state? It is almost here in this portion, 50%. This is very close to zero. It is not 100, so it is close to liquid. Okay, so here is the pressure, which is 160 kilopascal, and before starting solving the requirement of this problem, we prove that we are in the mixture region. Okay, because the V that we have is greater than VF and less than VG. Okay, fine. So this is the second requirement. So what also is needed? We need to find the enthalpy. Enthalpy is equal to mass multiplied by specific enthalpy. The mass that we have is 4 multiplied by H. So let's go and find H. H equal HF plus quality multiplied by HFG, or HG minus HF. So HF is equal to, from where we can get this value? From the thermodynamic table. So here is 160. Where is HF? This is HF. Okay, so here is the 160 and here is the HF. Okay, here is the HG, or we can benefit from the subtraction. Okay, this is HFG. HFG حكينا من قبل إنه تساوي HG minus HF. Okay, so we can benefit from this value, which is 209.9. So I will use this value and I'll use this value. So 31.21. So 31.21 plus X quality 0.158 multiplied by HFG 209, I think, 0.9. Let me check. Yes. So this is equal, if I use my calculator, then this is 0.58 multiplied by plus 31.2. So this is 64.37 kilojoule, and this unit from table per kilogram. Here it is. So this is the unit. Okay. Now I'll go back to the previous equation and substitute 64.37, and the answer is 257.48 kilojoule. Okay. The last requirement of this problem is to find the volume occupied by gas. So here is part D. We need to find Vg. Okay, Vg equal mass multiplied by specific volume of the gas phase. Or let me do first. So here this mass is mass of the gas phase. Okay. Now from where we can get this value? This value is unknown. But this value we can get it from the table, which is 0.123448. Okay. So this value we could find earlier the quality, which is 0.158, and this is equal, if you remember the general equation, mass of the vapor divided by mass total. So mass of the vapor will equal to X multiplied by M total, and this is equal to 0.158 multiplied by M total, which is 4. So if you use your calculator, you will find that this is equal to 0.632 kilogram out of 4. So only this amount is in vapor 4. So the volume occupied by gas phase is equal to 0.632 multiplied by Vg, which is 0.123448. If I use my calculator again, I'll find that this value is equal to 0.078 meter. Here is the second requirement. Okay, let me go back to the PowerPoint. So we could find the 4 requirements. Let's see another example, example number 7. So here in this example, determine the temperature, so temperature is unknown, of water substance at a state of pressure. So here is the first information, and here is the second information, enthalpy. Okay, so what we'll do, we'll go to solving board again. Okay, let us open a new page. So what do we have in this problem? We have water as a substance. Okay, we don't know the phase of this substance, only we know the chemical composition, which is water. We have pressure, which is 0.5 megapascal, very high pressure. Okay, or we can write it in terms of kilopascal. So if I convert it to kilopascal, what we'll do, will multiply it by 1000, so it will be 500 kilopascal. Okay, what else? We have enthalpy, so I'll write it here. So the enthalpy is 2890 kilojoule per kilogram. So what we'll do, we'll go to the pressure table. We'll go first of all to the temperature, to the water, saturated water table, and we'll benefit from pressure table. So let me go first. This is refrigeration. I'll go to the table A5, I think, yes, saturated pressure table. And I'll look for, because this table is in kilopascal, so this is why I convert mega to kilopascal. Now I look into the 500. Here is the 500. Okay, so 500 kilopascal, and we need to locate the enthalpy, which is whether it's between HFG or HG or HF. Okay, whether it's between them or not. So here is the enthalpies. I'll go down straight down. Okay, I'll be in the middle. Okay, until I reach 500. Here is 500. Okay, so actually I'm concerning about those values, 640 and 2007. Let me erase this value. So 640.09, okay, and 2704. Let me go back here. So here is the values. So we'll compare whether this value given in the problem between HF and HG. So HF is equal to 640.09, okay, and HG is equal to 2748.1. So is this value between them? Of course, 2890 is greater than, so this is correct, but it's not less than 2748. Okay, so this value 2890 is greater than Hg. So if it's greater than Hg, that means what? That means go to, as a result, go to superheated table. Okay, let me refresh your mind with this slide. So at a given pressure, where is it? Yeah, here it is. The given pressure, if the H given in the statement of the problem greater than Hg, that means go and benefit from superheated table. So دائما حكينا بهذا السلايد بنبدأ من الساتوريتد تيبل وبنشوف هل ال H اللي معانا أكبر من ال Hg اللي موجودة في التيبل. هذه تيبل، هذه القراءة من التيبل، وهذه القراءة من problem statement. Okay, so yes, go to superheated table. So let me go back here and let me use or go to superheated table. So here is the superheated table, or this is still saturated. Okay, so we go to superheated. Yeah, this is superheated table. Now I will locate the pressure, which is 0.5 mega. 0.5 mega, this is 0.4. Okay, here it is, 0.5 megapascal, and the first column represents the temperature. So here is 0.5 megapascal, and I need the enthalpy. Here is the enthalpy. This is the column for enthalpy. I will go down. So this is the column that I'm carrying over. Okay, this column. So what we'll do now, we'll try to locate 2000. So enthalpy given is 2890 kilojoule per kilogram. So is it here? Where it is? So this is 2800. Let me go closer. So this is 2855. This is 2900. So our value is here. So this value is 2890, which is between these two values. Okay. Now we need to find the temperature. Where is the temperature? The temperature must be between 200 and 250. Okay. So how we can find this temperature? So this temperature is unknown, and it's question asked about this value. How we can find it? Simply by doing interpolation. Let me go back to the solving board and let's do interpolation together. Okay. So what do we have? We have column for temperature and we have another column for enthalpy. We have three values. We have value 200, the temperature is unknown, and we have another value is 250. The corresponding H value of 200, let me erase this column. So the corresponding value of 200 is from the table 285.5.8, and the corresponding value of enthalpy to the 250 is 2961. This is from table. Okay. Now the value that we have is 2890. Okay, is it exact? Yes, 2890. Okay, so we need to find this value, this temperature. How to find it? Using interpolation. What we'll do, we'll say that the needed temperature is equal to 250 minus 200 divided by 2961 minus 2855.8. This is multiplied by 2890 minus 28885.8. Close brackets. Okay, all of them added to plus 200. Okay, as a result, the temperature is equal to, so let me use my calculator, 250 minus 200 divided by 2961 minus 2855.8 multiplied by 2890 minus 2855.8 plus 200. So this is 216.25 degrees Celsius. How to check that your value is correct? It must be between, sorry, must be between 200 and 250. So we could find that this temperature is 216.4. Okay, 206.25. So, which is between 200 and 250. Okay. Okay. So here another problem. What do we have here? Determine the internal energy. Internal energy is U for compressed. So here is the phase description. This is phase. Told us that this is compressed. Liquid water. This is the substance. And this is again the phase description, compressed liquid. At temperature 80 and pressure 5 megapascal. Using the data from compressed table, data from saturated table. Okay, we will find U from the compressed. Okay, or do you not? Do you know what? Because here mass is not given, I'll not find the internal energy. Please add here specific. Okay, so I'll find instead of capital U, we'll find U, and we'll find U from saturated table. Let me go to the solving board and start solving this problem. Let me open a new page. Okay, what do we have? We have pressure equal to 5 megapascal, and in terms of kilopascal, this is 5,000 kilopascal. Okay, and the question gave us temperature, which is 80 degrees Celsius. So we have two information. We have pressure, or we have two property, and we have temperature. It's mentioned that we have liquid, okay, water, sorry. So let me erase everything. دائما لما بتدرسوا من هدول الجداول استعملوا قلم رصاص عشان تقدروا تمسحوا الأشياء اللي بتكتبوها، غير هيك بصير الجدول عندكم مخرش إذا كنتوا طابعينهم طبعا. طيب هي ال saturated water دائما نبدأ من عنده pressure. So we have a pressure of 5,000 or 5 mega. So this unit is kilopascal. So I'll use 5,000. So here is 5,000. This is 5,000. And the corresponding Tsat is 263.94. Let me go back to the solving board and I write that the temperature Tsat is equal to 263.94, which is greater T given in the problem or Tsat. Tsat is bigger. So if the temperature that we have less than the Tsat, what is the action? Go to compressed table. Okay, go to compressed table. So we'll go to the compressed table, saturated, superheated, sorry, this is superheated, again superheated, where is compressed, again superheated, here is compressed. Okay, and I need to find pressure. This is the minimum pressure that this table starts with, 5 mega. Okay, it's there, موجودة. And I need to find 80. So here is 80. What is the corresponding value? I need specific internal energy. So this is specific internal energy, 333.82. So U specific is equal to 333.82 كيلو جول بير كيلوغرام. So هذه أعتقد كانت أول requirement data from compressed table. So we need also, this problem asks us to find the specific internal energy from saturated liquid table. So what to do? From which table? So go and find U from saturated, U from saturated table. Okay, but which table? Pressure table or temperature table? Now, if the state is very close to compressed and we could find the value in the compressed table, or if we could not find the value in the compressed. So in the previous part, we could find it in the compressed table, but assume that the pressure that we have is not there, because I mentioned we have 5 mega. Sometimes we have pressure 4 megapascal, so this value is not there. What to do? Do we need to use pressure table or temperature table? So the correct answer is you must benefit from temperature table. So this is a rule. Okay, if the value is not there in the compressed table, so if you did the check, this check, and you find that your value, yes, it's not in the saturated table. So remember, we start from the pressure table. Okay, and we compare our T value with the Tsat, and the value was less. So go to compressed. And fortunately, we could find it, but sometimes we could not find it. So do we need to go back to the pressure table? The answer is no. Go to the temperature table. So we must go to T equal to 80 without any check, okay, and find out your needed value, which is equal to UF, and this must equal to, so go back to to temperature table instead of pressure table. So remember, we start from here, from this table, and we go to 5000 and compare our T with this one. So now I'll not go to this table. Okay, I will take my U value from the saturated temperature table, and I need 80. So yeah, I'll go back to the temperature table, and I need 80, okay, as a starting value. So this is 80. And where is the corresponding value of U? Here it is. See, it's very close to the value in the compressed table. So the value here, 334.97. 0.97. See, the value is very close. This value we find it from the saturated table is very close to this value, but there is error. This is why in the problem statement he asks us to find the error involved in the second case. Okay, because the value we find it in part B is approximated, it's not exact. Okay, so this is approximation. So in order to find error, what we'll do, so percentage error is equal to approximate value minus exact divide by exact, between absolute value multiplied by 100%. And if you calculate the error, you will find it equal to 0.34%. Very small. So this assumption, going back to temperature table, give us very small error. If you by mistake do not refer the second bar to temperature table, to the pressure table instead, the error will be very huge. I'll show it to you. So this is wrong. This is wrong action. So if you stick to 5000 here, and you benefit from UF from this table, see, it's not 333, it is 1148. So this is wrong value, and the error will be very huge. Okay, so this is always the case. Whenever you could not find your value in the compressed table, go back to the temperature table. Okay, go back every time to the temperature table. Okay, so this is example 8. Example 9, I leave this example for you. Okay, try to solve this example, and the first one who will submit this example, I'll give him a bonus. So this is bonus example. Okay, so please record the video and submit it as we did earlier. Okay, so that's it for today's lecture. Next lecture will continue with example number 10, and this example will be the end of thermodynamic part. After that, we'll start with the heat transfer part. See you soon.